Hello, this is the lecture number 6 for the chapter integration. I'm discussing the exercise 7.3 and we have done up to question number 10. Now again the question number 11 just as question number 10 in which we have cos raised to power 4 2x and we have the even power. So for cos की power 4 2x you can write cos square का whole square. For cos square 2x you can write using the formula of cos square is equal to 1 plus cos 2x upon 2. So it will become 2x it is here, it will become 4. So be careful, some mistake I have done. So 1 plus cos 4x upon 2, find the whole square, it will become 1 upon 4, it will become 1 plus cos square 4x into plus 2 cos 4x. Now you can integrate 1 and 2 cos 4x. Again we have cos square 4x. So now you can convert into using the formula cos square as you have done. Cos square x is equal to 1 plus cos 2x upon 2. So it will become 1 plus cos 8x upon 2. It is equal to 4x and it equal to 1. Simplify and adding it. So it will become 8. It will become 4. So it is 8. It will become 8 here, it will be 4 and will be 4 here. So using the formula cos square x 1 plus cos 8x upon 2, adding it, it will become this. Integration of cos 8x will be sin 8x upon derivative of 8x, 8, and integration of cos 4x is sin 4x divided by the derivative of 4x which is equal to 4. Now in question number 12, sin in place of sin square upon 1 plus cos x, replace the sin square with 1 minus cos square x. Simple formula, 1 minus cos square is equal to 1 plus cos x 1 minus cos x. So 1 plus cos x will be cancelled out from the denominator. So you are getting plus will be cancelled out. So a plus b, a minus b. So it will be a minus sign here, minus sign here. So integration of 1 with respect to x is x. Integration of cos x will be equal to sin x. Now in question number 13, it is a very good question. It is cos 2x minus cos 2 alpha upon cos x minus cos alpha. Replace the value of cos 2x in terms of cos which is equal to 2 cos square x minus 1. Replace the formula of cos 2x in terms of cos 2 cos alpha is equal to 2 cos square alpha minus 1. 1 say 1 will cancel out. Take 2 common. It will become cos square x minus cos square formula cos square alpha. Using a formula of a square minus b square, a plus b, a minus b. The negative cos x minus cos alpha will be cancelled out. So I am getting only cos x plus cos alpha. Now integrated, be very careful. 2 cos x with respect to x, integration plus integration of 2 cos alpha, integration of 1. Why we have replaced 1 here? Because cos alpha is a scalar, we don't have x, we have cos alpha. So it will be a scalar, so we have to integrate only 1 whose integration is x. Integration of cos x is sin x. Now cos x minus sin x upon 1 plus sin x. Now in place of 1 plus sin x, you can write sin x plus cos x whole square. Because sin x plus cos x whole square will be equal to 1 plus sin 2x. Because if you do the whole square, it is sin square x plus cos square x plus 2 sin x cos x. So sin square plus cos square is equal to 1 and 2 sin x cos x is sin 2x. So let sin x plus cos x is equal to t, whose derivative will be the numerator. Dx upon dt is equal to sin x minus cos x. ये cancel हो जाएगा. This dt upon cos x minus sin x, replace it. This will cancel out. By replacing the value of dx, you have to integrate only 1 upon t square, that is t की power minus 2 plus 1 upon minus 2 plus 1. Arrange the negative sign, replace the value of t which is sin x plus cos x. In question number 21, sin inverse cos x. So you can have to remove this sin inverse. You know that inverse trigonometric function. So in place of cos x, you write sin 90 minus x. So sin inverse sin theta is equal to theta. So it will be only equal to pi by 2 minus x. Sin inverse sin x is equal to x. So you can integrate pi by 2 minus x. So integration of pi by 2 only for 1. You can take pi by 2 common because it is a scalar. And integration of x. And integration of x is x square upon 2. And integration of 1 with respect to x is x. Now in question number 15. It is a good question. It is 10 cube 2x into sec 2x. It is cube. So in place of 10 cube, you write 10 square 2x into 10x. See it very carefully. For 10 cube, you write 10 2x into 10x. For 10 square, you write sec square x minus 1. That is sec square 2x minus 1. Now you let sec 2x is equal to t because its derivative will be this. So that is why we have break like this. So let sec 2x is equal to t. So dt upon dx will be equal to sec derivative is sec x into 10x into derivative of 2x which is equal to t. So this sec x into 10 2x will be cancelled out by replacing the value of dx, which will be this. So after putting the value of dx, you will get t square minus 1 dt upon 2. You know the integration of t square, t cube upon 3. You know the integration of 1 with respect to t is equal to t. Replace the value of t as sec 2x. Replace the value of t as sec 2x. Now see the integration of 10 to the power 4. Now integration of 10 to the power 4, you have to break it into 10 square into 10 square. For one 10 square, you write sec square minus 1 and leave the second 10 square as it is. Open the integration, break into 2 integration. Now this 10 square integration, you can easily do it by breaking into sec square minus 1, because the integration of sec square is 10x and integration of 1 is x. We can do this like this. But say it in the first integration. Sec square into 10 square, you let 10x is equal to t, because derivative of 10x will be sec square and this will be cancelled out when you put the value of dx. So let 10x equal to t only in this integration, not in this, because we have done this integration already. So this will become t square dt. The sec square will cancel out when we put the value of dx. So integration of 10 square is t cube upon 3 and replace the value of t as 10x. Question number 17 is somewhat easy. Sine cube x plus cos cube upon sine square into cos square. Break into 2 integration. This upon this, this upon this. 1 sine square will be cancelled out. Sine upon cos square. Cos upon sine square. So sine upon cos square, when you simplify it, will become sec x into 10x. Cancel out this cos square with cos square. So cos upon sine square will be equal to cosec into cot x. And we know the integration of sec x into 10x, which is equal to sec x. And we know the integration of cosec into cot x, which is equal to minus cosec x. Now in question number 18, see it very carefully, because you have to use the identity for cos 2x in terms of sine, because we have 2 sine square x here. We have 4 formulas for cos 2x. 2 cos square x minus 1, 1 minus 2 sine square x, cos square x minus sine square x, and 1 minus tan square upon 1 plus tan square. So I am using the identity for cos 2x as 1 minus 2 sine square x, because this will cancel out this. It will be 1 upon cos square, which will be equal to sec square, and we know the integration of sec square as 10x. Now question number 19 is somewhat tricky. It is dx upon sine x into cos cube x. Multiply and divide in the denominator by cos x. So sine upon cos into cos ki power 4x. Take this cos ki power 4x into numerator will be equal to sec ki power 4x, and sine upon cos is 10. For sec ki power 4, you can write sec square into sec square and let 10x equal to t, because when you put the value of dx, dt upon dx will be sec square. 1 sec square will be cancelled out. So dt upon t. Now replace this sec square as 1 plus tan square, because we know the value of 10x equal to t. So it is a good question. So replace the 10x equal to t, which is 1 plus t square upon t. 1 upon t, t square upon t. It will become 1 upon t, t. And you integrate it, log t and t square upon 2 plus c. Replace the value of t, which is 10x and 10x. So 10 divide and multiply by cos x. Take cos ki power 4 into numerator will become sec ki power 4. Sec square into sec square implies so sec ki power 4. Let 10x equal to t. When you replace the value of dx by differentiating it, 1 sec square will be cancelled out. It will become sec square, and then integrate. So it is a good question. Now question number 20. Again, we have cos 2x, just as we have done is question number 19. There we have used the formula of cos 2x as 1 minus 2 sine square x. We'll use it here as cos 2x as in terms of cos and sine. So cos 2x is cos square x minus sine square x, because in the denominator we have sine x into cos x. So in the numerator, use the identity a square minus b square, a plus b, a minus b. So one of the term of this, the denominator will be cancelled out. So it will become cos x minus sine x upon cos x plus sine x. You take your own time how this will become this. A square minus b square formula in the numerator. A plus b, a minus b, and one of the term will be cancelled out. Now you can let cos x plus sine x is equal to t. The numerator will be cancelled out. It will become only equal to 1 upon minus 1 upon t. Whose integration is this. Now it is a very good question. Question number 22. 1 upon cos x minus a, cos x minus b. So be very careful. Multiply and divide the numerator by sign b minus a. It is a tricky question. You take full time to do this question 2 to 3 times. So multiply numerator denominator by sign b minus a. So in the numerator we have b minus a. So in place of b minus a you can write x minus a minus x minus b, because x will be cancelled out with x and it will become b minus a. The same will be this. Why we have done this? In place of b minus a, x minus b, because we can use the formula of sine a minus b in the numerator, which is equal to sine a cos b minus cos a sine b in the numerator. Break into two integration. This upon this will become cos x minus b cancel cos x minus b, tan x minus a, and this upon this will cos x minus b cancel or cos x minus a. It will become tan x minus b, and you know the integration of tan sec log sec x. 10 x minus b integration is log sec x minus b in the modulus. Integration of 10x is log sec x. Integration of 10x is log sec x. Question number 24. It's somewhat easy if you see it very carefully. E की power x into 1 plus cos x is the derivative, 1 plus x is the derivative of e की power x into x. So you let e की power x into x is equal to t. Find dt upon dx by the product rule in the left hand side, and it will become e की power x into 1 plus x. Replace the value of dx it here. This will be cancelled out with this. You are getting only 1 plus cos square, and 1 plus cos square is equal to sec square, t with respect to t, and you know the integration of sec square, which is equal to tan t. Replace the value of t. Question number 23, it is very easy. You break into 2. This upon this will become 1 upon cos square. This upon this will become 1 upon sine square. And 1 upon cos square is equal to sec square. 1 upon sine square is equal to cosec square. So 10x cot x. Integration of minus cosec square x is minus cot x, and integration of sec square x is tan x. So this is the completion of the exercise 7.3, which is based on the trigonometric identities, and we'll discuss the special integral in the next lecture. Thank you.